Good day everyone. For today's discussion, I'm going to discuss linear programming simplex maximization method containing equal symbol. But before that, let me introduce myself. I'm Christine H. Wiley Bing, and I'm taking up Bachelor of Science in Civil Engineering at University of Mindanao. Simplex Method of Linear Programming by George B. Danzig. The simplex method devised by George B. Danzig in the late 1940s revolutionized linear programming and optimization. This algorithm provides a systematic approach to solving problems where a linear objective function must be optimized within a linear inequality constraint. Danzig's work laid the foundation for efficiency navigating the solution space of such problem, enabling decision-making across various fields. Despite advancement in optimization algorithm, the simplex method remains a fundamental tool valued for its simplicity and effectiveness. George B. Danzig, an American mathematician, professor at Stanford University, is renowned for developing the simplex algorithm in the 1947. This groundbreaking method revolutionized optimization by providing a systematic approach to solving linear programming problems efficiently. Danzig's work has had a profound impact across various fields, enabling practical solutions to complex optimization challenges. Importance of simplex methods solving linear programming problems. Efficiency. The simplex method is a powerful algorithm for finding optimal solution in linear programming problems. Versatility applicable to a wide range of real-world optimization challenges. Iterative process, successive iterations converge towards the optimal solution. The simplest method is highly efficient, versatile, and operates through iterative steps to find optimal solution in linear programming problems. Its efficiency makes it preferred choices for diverse real-world optimization challenges, while its iterative nature ensures convergence towards the best solutions. Linear programming can be defined as a technique that is used for optimizing a linear function in order to reach the best outcome. This linear function or objective function consists of linear equality and inequality constraints. We obtain the best outcome by minimizing or maximizing the objective function. So linear programming is like a math tool we use to make the best decisions. Imagine you have a problem where you want either make a something as big as possible or something as small as possible, like profit or cost. Linear programming helps us to figure out the best way to do that. So objective function, this is basically what you want to maximize or minimize. It's usually something like profit, cost, or efficiency. So this is like part of your goal. So constraint, these are the rules or limit you have to follow. They can be things like budget, time limits, or available resources. Constraint can be either equalities or things that have to be exactly a certain value, or inequalities where is things that have to be less than or equal or to greater than to a certain value. So linear programming is said to be in standard form if the constraints are modeled as equalities. So in linear programming, standard form means representing constraints as equalities, not equalities. This simplifies problem solving using methods like the simplex algorithm. What is simplex method? One of the most popular methods to solve linear programming problems. So, simplex method is an iterative process to get feasible optimal solution. And in this method, the value of the basic variables keeps transforming to obtain the maximum value for the objective function. Simplex method, the optimal solution to a linear programming problem, if it exists, always occur at one of the corner points of the feasible solution space. So the simplex method focuses on corner points or vertices of the feasible solution space. to find the optimal solution. It moves step by step between these corners, improving the objective function value until the best outcome is reached. Component of linear programming. So objective function, think of this as the main goal or target you're trying to achieve. It's like a recipe for maximizing something such as profit, efficiency, or output. In linear programming, the objective function is represented as a linear equation. For example, z is equal 3x plus 2y represent an objective function where z what we're trying to optimize, and x and y are these decision variable that we can adjust. So constraint are the rules or limitation that restrict the possible solution to the problem. They could represent things like resource constraints, physical limitation, or any other condition that define the feasible region of our solution. Constraints come in two forms. These are inequality and qualities. So inequalities, these set boundaries or limits on the decision variable. For example, 2x plus y greater than or equal to 10 represent an equality constraint that limits the total of amount of resources available. So in inequalities, this represents strict condition that must be met exactly. For example, x plus y equal 5 represent an equality constraint that specifies a fixed quantity that needs to be achieved. Linear programming model in equation form. So linear programming models are mathematical representation of optimization problems. These models consist of an objective function and a set of constraints. The objective function defines what you're trying to maximize or minimize, while the constraint impose limitation on the decision variables. So the development of simplex method computation facilitated by imposing requirements on the linear programming constraints. So the simplex method is an iterative algorithm used to solve linear programming problems. It's facilitated by imposing certain requirements on the linear programming constraints. So those are all the first are all the constraints are equation with non-negative right hand side or RHS. So this ensures that constraints are in form of equalities like greater than or equal to, less than or equal to, allowing the simplex method to solve efficiently from one feasible solution to another. So second is all variables are non-negative. So this restriction ensures that feasible region is bounded and allow the simplex method to explore the solution space effectively while guarantee non-negative values for decision variables. Simplex maximization problem containing equal symbol. So in a maximization problem, if the constraint has a equal symbol, we add a slack variable or Sn. So equal x plus y equal to x. So if we add the slack variable, so it become x plus y plus slack 1 equals 2. So in linear programming, we have when you have an equation constraint, example is that x plus y is equal to, you typically convert it into equality to fit the standard form linear programming problems which involves inequalities like less than or equal. So if for a maximization problem, you want to convert all the constraint into inequalities of the form greater than or equal to. So for the constraint x plus y equals 2, you introduce a slack variable, or let's call it S1, to turn it into inequality. So it will become x plus y plus slack 1 equals 2. Now, to satisfy the condition x plus 2 or x plus 2 equals 2, slack 1 must be such that the sum of x, y, and s1 is equals to 2. Since we're dealing with a maximization problem, the goal is to make x plus y as large as possible, while still satisfying the equality. So this is where the slack variables comes to play. By adding slack variable or s1, you allow x plus y to be potentially greater than 2. So the slack variable the slack variable absorbs and exceeds beyond 2, ensuring the equality constraint is met. So the introduction of slack variable transform equality constraint into inequality constraint, enabling the problem to be solved using standard linear programming techniques. So this is our word problem number 1. On an 80-hectare farm, a farmer can grow rice and corn. In comparison to corn, which needs 6 pesticide unit and 12 fertilizer unit per hectare, rice only need 8 insecticide unit and 4 fertilizer unit. He has at least 240 units of fertilizer and at least 180 units of insecticide on hand. He makes 30,000 pesos on average per hectare of rice and 20,000 each hectare of corn. In order to increase his average profit, how many hectares of each crop should be planted? So this is our word problem number 1 solution. So so this is our decision variable. So let define the x is equal to hectare of rice to plant, while y is equal to hectares of corn to plant. So to formulate the objective function, we want to maximize the total profit, which is given by z is equal to 30,000 x plus 20,000 y. To set up the constraint, so this is our the constraint. So x and 8 uh, 8x plus 6y less than equal to 180 is a pesticide constraint. So it means that the total amount of insecticide used should not exceed the available insecticide. So 8x plus 6y less than equal to 180 is a pesticide constraint. So while in fertilizer constraint, the total amount of fertilizer used should not exceed the available fertilizer, which is 4x plus 12y less than equal to 240. And in non-negative constraint is x is greater than equal to 0 and y greater than or equal to 0. So now let's solve for linear programming problem using the simplex method. So first, we convert the inequalities to qualities. So these are the equalities. 8x plus 6y plus slack 1 is equal to 180. And 4x plus 12y plus slack 2 is equal to 240. So step 2 is simplex W. So these are the table of simplex W. And so next step is we perform the simplex iteration. So these are the simplex iteration. So we have 3 iteration. So in pivot column X and pivot row slack 1, because 8 is smaller ratio. So here is 8 then X. In iteration 2, so in column Y, slack 2, 10, 4 is the smaller ratio. So iteration 3, so non-negative interest in the objective roles, the optimal solution is reached. So after performing the iteration, we got the final W. So these are the final W, which is the simplex iteration. So from the final W, or the simplex iteration, we can read the optimal solution, which is x is equal to 12.5 and y is equal to 10. So, the farmer should plant 12.5 hectares of rice and 10 hectares of corn to maximize his average plant. So this is our word problem number 2. The Davao Appliance Center has 2,400 cubic feet of storage space for refrigerator. The larger refrigerator comes in 60 cubic foot packing crates, and the smaller ones comes in 40 cubic foot crates. The larger refrigerator can be sold for 1,250 pesos profit, while smaller ones can be sold for 1,150 pesos profit. If the manager is required to sell at least 50 refrigerator each month, how many large refrigerator and how many small refrigerator should he order each month to maximize profit? So word problem number 2 solution. So to define the decision variable, let x is equal to number of large refrigerator to order and y is equal to number of small refrigerator to order. So this is our objective function. So we want to maximize the total profit, which is given by z is equal to 1,250x plus 1,150y. So these are constraint. So the storage space constraint, the total storage space used by the refrigerator should not exceed the available storage space, which is 60x plus 40y less than equal to 2,400. So in minimum sales constraint, so the manager must sell at least 50 refrigerator each month. So x plus y less than equal 50. So in non-negative constraint, so x is greater than or equal to 0 and y is greater than or equal to 0. So now let's solve the linear program problems using the simplex method. So step 1, we convert the inequalities to equalities. So we add slack variable. So in 60x plus 40y plus slack 1 is equal to 2,400. And negative x minus y plus slack 2 is equal 50. So we perform the simplex W. So these are simplex W. So in our iteration, we perform um, iteration until the optimal solution is found. So I will now perform the simplex iteration provide with the final optimal solution. So in iteration 1, pivot column X, pivot row slack 2 because 1 over minus 1 is the smaller ratio. So in iteration 2, pivot column Y, pivot row slack 2 is 40 and 60. And step 4, iteration 3 is a non-negative in the objective row. So the optimal solution is reached. So in a final tableau or the simplex iteration table, so this is our final tableau. So we found the optimal solution in a simplex iteration or final tableau. So these are our optimal solution. So 6 x is equal to 0 and y is equal to 250 is our optimal solution. So the manager should order 0 large refrigerator and 250 small refrigerator to each month to maximize profit. So this is our word problem number 3. A school is organizing a fundraising event where they plan to sell two types of items, t-shirts and cups. Each t-shirt yields a profit of $8, while each cup yields a profit of $5. The school has 300 units of fabric and 200 units of embroidery thread available. So each t-shirt requires 2 units of fabric and 1 unit of embroidery thread. So while each cup requires 1 unit of fabric and 2 units of embroidery thread, if the school aims to maximize profit while ensuring all available resources are utilized, how many t-shirts and caps should they produce? So this is our word problem number 3 solution. So these are decision variables. So let x is equal to number of t-shirt to produce and y is equal to caps to produce. So in our objective function, our objective function is to maximize the total profit of z is equal 8x plus 5y. So these are constraints. So to fabric constraint, the total fabric should not exceed the available fabric or 2x plus y or less than equal to 300. And second is embroidery constraint. So the total embroidery thread used should not exceed the available embroidery thread x plus y or less than equals to 200. And non-negative constraint is x is greater than 0 and y is greater than 0. So, well, so use the we're going to solve the linear programming. So let's convert the inequalities to equalities. So 2x plus y plus slack 1 is equal to 300. X plus 2y plus slack 2 is 200. So these are equalities because there has slack variable. As I said earlier, na it's the if linear the simplex method is if equality we must add slack variables. So simplex W. So these are simplex W. So in solving using the simplex method, so after converting the inequalities to qualities, so let's proceed to simplex W. So these are simplex W. So perform sex is to perform iteration. So in pivot column X and pivot row slack 2, so 1, 1. In iteration 2, pivot column Y, pivot row slack 1 is 2 and 1. So in iteration 3 is non-negative increase in the objective row and the optimal solution is reached. So this is our final tableau or simplex iteration. So as we can see here, we can read now the optimal solution. So these are optimal solutions. So x is equal to 15 while y is equal to 10. So the school should produce 15 t-shirts and 10 cups to maximize profit while ensuring all available resources are utilized. In conclusion, the linear programming simplex method offers a systematic approach to optimize solution in problems with linear constraint. So by introducing slack variables and converting inequalities to qualities, the method effectively navigates through feasible solution toward the optimal solution. Through iteration of pivot operation, it progressively progressively improves the objective function while ensuring adherence to constraint. So we've seen how the simplex method efficiently handles problem where constraints are modeled as equalities, ensuring that each iteration moves closer to the optimal solution. So its clarity and effectiveness make it a valuable tool for decision making across various domains. So from resource allocation to production planning, I'd like to um, so yeah, those are the conclusion about my discussion. So thank you for watching. I'd like to extend my gratitude for listening to my discussion on the linear programming simplex method. If you have any further question or topics you'd like to explore, feel free to ask. And thank you for your attention. Thank you for watching.